Okay, we've been talking about time, and you know that I have a series on time itself from 2 months ago. In August I put that up. So we went over the basics of how to understand time, because it's a very gargantuan force. It's a mystery. And Larry is my friend. He knows a lot of information and scientific knowledge. So he came up with more specific stuff as we got into time, things that I specifically didn't know about. So I'm going to let Larry explain this, and it has to do with the mathematical expression of time.
Yeah, the idea of whether or not time is the same in all places or not. If it passes the same, like throughout the universe. According to the special theory of relativity, it does not pass it the same. It depends on the rate of the observer. That the time is a function of time and distance and rate are all functions of one another. Just like electric current and electric voltage, and power. And
go into that electric analogy.
Yeah, so like Ohm's law is E is equal to IR, where E is the voltage, I is the current, and R is resistance. When there is resistance, it produces heat, which is power. So that's measured in British thermal units, and it's measured in watts and calories.
Watts.
Yes.
Watts or calories.
Yes, watts is horsepower, like the same kind of thing. But anyway, they're all functions of one another. All of these things are functions of one another. And the basic law called Ohm's law is E is equal to IR. Because the speed of light is considered to be constant, it's sort of like the foundation of most of the
standard measuring stick.
Yeah, it's the stick, by which we measure things, because movement makes everything relative. And time varies in the same kind of relativity. Time is also relative to movement and direction of movement. And, but mostly just movement itself. Because if you are, but the movement is in relation to something, like the time is measured in between two things which have a relation to one another. If there are 2 points that are moving in space, then they are related to one another, by how fast that they are, moving in relation to one another. And therefore, if there's more movement, if it's going faster, this is what you call rate, then, the closer it approaches the speed of light, the slower time goes. And there's a function for this, which is called the Lorenz Transformation. And it's sometimes called the Lorentz-Fitzgerald contraction when you're thinking about it in terms of distance. Because along the axis of movement, the object contracts, in relation to being observed from outside, so from that point of reference, that viewpoint, then the object becomes a flat disk, if it were a sphere.
Does it change the shape of the galaxies then?
It changes the shape of whatever is moving in relation to something else. When you look at something else, the thing is that this function, exists in both directions. Because the movement, is relative.
It's
dependent upon the observer.
So can we figure out the direction the solar system or any star system is going by looking at the shape of the disk of the planetary orbits? Can we find out the direction it's going because it's flattening itself?
Yeah.
Is that
it is not at all likely unless, we were able to see something, with the instruments that I can't remember seeing. But, because, you're observing something that's moving near the speed of light, if you saw any contraction at all. The function of this transformation is the square root of 1 minus b squared over c squared. Mm-hmm. So that is the factor that you use to determine these relationships, in regard to the speed of light and time in motion and distance.
Well, we opened up a large can of worms here because now we're going to have to talk about space, and I didn't really do a series about space yet. So the nature of space and measuring distance is also very
this is relative to us,
vast.
Like how far away it is from It's how high above me it is, how far beneath me it is, or how far behind me it is.
Yeah.
How far to my right or left.
Well, it's like
they create this concept of space around this relationship of observation of reality.
Well, it's like spatial reality. Yeah. Because I was because it reaches like a limit of upload.
Oh yeah. Okay.
Hopefully save it.
Yeah, I got it anyway.
It's live now.
Might be interesting to see if there's any other sessions that have people on relativity, because it's all about relativity.
There probably are. We can jump into that. The thing is just now the what I'm going to tell you what's